Hello everyone, welcome to the class. In today's class, we're gonna study the new chapter which is System of Particles and Rotational Motion. So, in order to understand the system of particle or rotational motion, or before we study rotational motion, we need to understand a very important concept which is called center of mass. And you know what? This chapter is very important as per your JEE main and JEE advanced exams. So let me give you an example. Imagine a cricket bat, or you consider a rotation of Earth around the sun. Do you think these are single particles? No, these are not single particles. They are basically made of millions of particles. So, in order to study, you know, a cricket bat or Earth, which is made up of millions of particles, it is very difficult to study the motion of each particle individually, right? It is impossible task. So the physicist decided that instead of studying, the individual particle motion, we consider that the entire object is made up of one imaginary point. That means, in simple words, I can say this entire object is replaced by, if you replace this entire object, replaced by one imaginary point, one imaginary point, and that imaginary point is nothing but your center of mass. So we understand the motion of this point, we can easily understand the motion of entire body, right? So let me ask you a question. If you understand this up to this point, so let me ask you a question. Can we treat a cricket bat as a single particle, or why do we need this imaginary point? Now let's understand why we should study rotational motion. You already know there are two types of motion, that is translatory motion and rotational motion. Even we have a vibratory motion. So, translatory motion is basically the motion along a straight line, like along only one direction, we can say, right? So, why we need this rotational motion? Because rotation is everywhere in your daily life. If you see, it's everywhere. Let me give you a very real life examples that involve rotation. First example, you see, this is door rotates about its hinges, right? Yeah. This is again another example. If you see, a wrench rotates about a nut. Yeah. Again, ferris wheel, this also rotates some particular axis. Bicycle wheel, again it rotates about a particular axis. And cricket bat, this also rotates. When you cricket bat rotates while playing a shot, right? Again, you have a rotating machine also. So these are all the examples that you see in your daily life, right, which involves rotation. So basically, whenever a force which is acting, it tends to rotate an object. So in that case, the ordinary Newton's law are not sufficient. So we need to understand new concepts. What what are the new concepts like torque? We will discuss this one by one in the classes, okay? And another one is angular momentum, and we need to understand moment of inertia, right? So Newton's law is not sufficient, so we need to you know we need new concepts like torque, angular momentum, moment of inertia, and center of mass. So today we're going to focus on center of mass, okay? So that's why this rotational motion is very important, uh, foundation of, you can say that, foundation of higher mechanics, right? And of course it has very high weightage in JEE main and advanced. And in order to understand the advanced mechanics, we need to understand this rotational motion. And you can also connect this rotational motion with your daily life examples, yeah, applications, you can say. right? So it is very important. So in today's class, it's not about that we need not to, memorize the formula. We need to understand the physics behind it. So this chapter is famous for conceptual and application based questions. So don't memorize formulas, understand the physics here. Okay, now if you understand the translatory motion, that is the motion around that is the motion in only one particular direction, that is if x axis or y axis or z axis is changing with time, that is a translational motion. Okay, and let me give you an example. Let me ask you a question that the question is, which uh, of these examples involve translatory motion or rotational motion? So one is cricket bat. You need to comment down. Okay, cricket bat. Second is, let's say, wheel, bicycle wheel. Okay, and third, I'll give you another example, ball. Okay, so you need to tell me which one is translatory motion or which one is rotatory motion. Okay, yeah, okay. So now what we gonna learn in today's class? We're going to learn about the most important things in today's session. So, by the end of today's class, you'll be able to understand the system of particles. You'll be able to derive an expression for, center of mass. Today, you will be able to solve the center of mass problem, basic to JEE level. And today, you will understand the motion of center of mass. And lastly, you will understand the concepts that is used in JEE main and advanced questions. So, basically strong concepts and you need to practice, and that will lead to JE success, right? Let's go for it. So let me give you a very simple example in order to understand the single particle and system of particles. Let me give you an example of a tennis ball. Example of tennis ball. Let's say if you throw a tennis ball, okay, we can treat this tennis ball as a single particle. Okay, because we are interested in its overall motion. So if you throw a tennis ball, okay, so we can treat it as a single particle. Okay, so because we consider that it is only made up of one mass, or only one mass is present, then it is a single particle, and you can describe its motion, uh, you know, by using Newton's law. So we can treat this tennis ball motion as a single particle motion because we are interested in its overall motion. But let me think of another example. Okay, another example, let's say bicycle. So can you treat this bicycle as a single particle? No, because it is made up of various parts. Let me give you an example. You have wheels, you have you have a handle, okay, you have other parts, paddles and many other parts, right? Chain, etc. So we cannot treat this bicycle as a single particle. So even another example, if you take cricket bat, again, you cannot treat a cricket bat as a single particle. It is made up of many particles, right? So these types of objects, if you consider now, which is made up of many particles, that is called system of particles. That means system of particle means many masses are present. And if many masses are involved, so it is very difficult to study each particle separately. It's very difficult to study the motion of individual particle. No, we cannot do that. Practically, it's not possible. So what we can do is we consider that this entire object is, we consider this entire object is equivalent to, this is equivalent to one point. One, this is equivalent to 1 point. Okay, this is equivalent to 1 point, and that point is nothing but your center of mass. Okay, so basically I have given you example of tennis ball, and I have given you example here is of bicycle and 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 cricket, right? So in order to study the motion of various masses, we consider that this entire object is may equivalent to a single point. That means the entire mass of this body is supposed to be concentrated at a single point. Let's say this is the single point where the entire mass of the body is concentrated, and that equivalent point is known as the center of mass. So center of mass is basically is supposed to be where whole mass of object is concentrated, right? So again, if I ask you another example, like truck has 1,000 parts, we cannot treat truck as a single particle. No, we cannot do it. Okay, so in that case, again, we need to consider that uh, uh, there is a uh, there is a equivalent point, or there is a center of mass where the whole mass is supposed to be concentrated. Let me give you some other examples, real life examples that you see. One example is hammer. Okay, again, if you see this bell, it balances about a particular point, है ना? And what is that point? That point is near to the center of mass, or you can say that it is the center of mass, right? Another example is cricket bat. You know, when you balance the cricket bat on your finger, so that means it balances about a particular point, and that special point is nothing but your center of mass. That means the whole mass of the bat is supposed to be concentrated at a particular point. Another example, you see the rocket. Again, we can analyze the motion of its center of mass during launch. Even though the fuel burns, mass changes, but engineers can easily analyze the rocket using the motion of its center of mass. Another example, if you see, that is the earth moon system. You see, the earth and moon, they revolve around their common point, their common center, and that center is nothing but that center is known as barycenter, and this is nothing but center of mass. So even earth and you can say moon, that revolve around a common point, and that point is nothing but a center of mass. Another example that you can see in is boat example. You see, if the two people are sitting in a boat, okay, if one person walks forward, then what happens to the boat? It will move backward. Why? Because there is no horizontal force which is acting on the system. So, and its center of mass is also fixed. And there is no horizontal force which is acting on the system. Okay, that's it. So this is an example. You have to think and answer. If the person walks inside a stationary boat, does the center of mass of person and boat will change or not? And you have to assume that there is no horizontal force acting. Okay. So this question is for you and you can do it. And another thing is the definition of the center of mass. So I hope up to this point everything is clear. So we can move to the definition of center of mass, and I have many times already told you what is the definition of center of mass. It's basically the point where the whole mass of the body is supposed to be concentrated, right? And mathematically we can write that the center of mass of system of particle is a point whose position vector is mass weighted average of position vector of all the particles in the system. We will understand this definition mathematically, okay, in the coming slide. Till now, you just understand that what is center of mass? Center of mass is a where point where whole mass of body is whole mass of body is supposed to be concentrated. Supposed to be concentrated. Okay. So imaginary point. What are the key points that you need to remember? It is an imaginary point. Okay, and it depends upon the mass distribution. Very very important. Okay, and of course it is independent of external force. And lastly, for a geometrical, for uniform bodies, it lies at the geometrical center. You see, this is a uniform body, uniform road. If uniform road, then it will lie at the center of the, you know, road. Even if you have ring, the center of the ring, that will be the center of this, because this is a uniform ring. Again, if you consider a uniform disk, so the center of mass is a point which is at the center of the disk. Another example, sphere. Again, the center of point will lie at the center of mass will lie at the center of the sphere. And for a semicircular uniform road, again it will lie at the center of the semicircular road. So it's very very important tool in order to study the motion of complex system as well. Okay, so in today's class we're going to discuss the basic ones. Okay, now another thing, let us calculate the center of mass for a two particle system. Okay, let us consider there is a body. Okay, let us consider there is a body, and in this body we have only two particles, m1 particle and m2 particle. And they are located at a distance. Let's say this is m1 particle and this is m2 particle, and they are located at a if you, let's say they are in x direction, so they are located at a distance x1 and 2. So and the center of mass position will be, let's say, this is the position of center of mass, which is in the middle of m1 and m, let's say. And this is the origin from where we can measure the position of the particles. Okay, this is my x direction, this is my y direction. So the particle is in x direction. So this is x1 and this is x2 position. And the center of mass will lie at the middle of the two masses. Okay, this is the x, this is the position of center of mass. Okay, so the position of center of mass is given by this formula, that is m1 x1 plus m2 x2 divided by the whole mass of the body, that is m1 plus m. Okay, let me give you the definition. Center of mass of a system of particle is the point whose position vector is mass weighted average of. So mass weighted average, that is, here it is m1 x1 plus m2 x2, okay, divided by position vector of all the particles m1 plus m2. Okay, like that. So this is very important, very very important. You should understand this. Okay, so okay, so center of mass is always, there is a tip that you need to understand. Center of mass, if the two masses are same, m1 is equal to m, then it will lie in the middle. But if m1 is greater than m2, then the center of mass position will shift towards heavier mass. Please note down, this is very important. Heavier mass. Always understand this thing, that if m1 is greater than m2, if m1 is greater than m2, then it will always shift towards shift towards heavier mass. Heavier mass. That is center of mass position. Center of mass. You see, this is the x1 position. That is the position of m1 mass. Okay, x1 is the position of m1 mass. And you can measure the position by considering a reference frame. So let's say, firstly you need to consider a reference point, that is the origin. So x1 is the position of m1 mass, x2 is the position of m2 mass from the origin, and XCUM, that is the position of center of mass, that XCM. Okay. So in that case, you see, so we can simply write this thing, that we can simply write that XCM, that the center of mass position, that will be given by the m1 x1 plus m2 x2 divided by the whole mass of the body, that is the m1 plus m, right? Clear? You see, the total mass of the body is m1 plus m2, and XCOM, that is the position of the center of mass from the origin. Okay. And x1 is the position of the m1 mass, and x2 is the position of the x2 mass from the origin, and XCM is the position of this center of mass. Okay. So by definition, we say that mxcm is m1 x1 plus m2 x2. So from here you can find the center of mass position is m1 x1 plus m2 x2 divided by the total mass of the body. So you see, the center of mass of a system of particle is a point where the position vector, whose position vector is the mass weighted average of position vector of all the particles in the system. So mass weighted average of all the particle in the system. That is, here we have two particles. So that is m1 x1 plus m2 x2. So that will be the position of the center of mass. Okay. Similarly, if you have a case, let me give you a case. If you have a case one, let's say if I consider that m1 mass is equal to m2 mass, then what will happen? Then what will be the position of center of mass? Then the center of mass position will be m1 plus m1 and m2 both are, let's say, equal to m. Okay, so I can write mx1 plus mx2 divided by the total mass of the body, that is m plus m. So simply you can write x1 plus x2 divided by. So always remember, if we have the two masses, equal masses, then the position of center of mass is simply the sum of x1 plus x2. The sum of x1 plus x. Okay. Now, again, the second case I want to discuss is case number two. That is also very important. The second case is that, let's say if you have three particles, okay, we can generalize it to the n particles. Let's say if you have three particles, then the center of mass position, let's say all the three particle is in x direction. So then it will be m1 x1 plus m2 x2 plus m3 x3 divided by the total mass. Okay. And I want to discuss one more case. Let's say uh, if you have n particles, okay, then what will be the case? For the system of n particles having masses m1, m2, m3, and at position vector, let's say r1 vector, r2 vector, r3 vector, and rn vector. So in that case, what will be the scenario? Let's say this is m1 mass, and in order to identify the position, you know, in space, we draw a reference frame first, which is x, y, and z axis. Okay, and we consider our origin from where the position of all the masses can be calculated. So we draw a position vector starting from origin to the mass of the body. So we draw a straight line joining the origin to the mass of the body. That will be given the position of first vector, which is r1 vector, and that will be the position of my first vector. Similarly, r2 is the position of, again you can draw, you can find the position of second particle. Similarly, you can draw another position vector which will give you the position of the uh, you know third particle, and so on. So the if you have a center of mass, okay, let's say if you have at any point, this is the position of the center of mass of the body, okay, m center of mass, okay, and this position, here the position vector is rcm. So the position vector, uh, if you want to find the position of center of mass of the body in vector form, it will be given by summation I1 to n, MIRI divided by summation I1 to n number of particles divided by m. Similarly, you can write in Cartesian coordinates also. The x center of mass is summation MIXI divided by summation MI. Similarly, YCM is uh, MIYI divided by summation MI. Similarly, for Z coordinate, it is MIZI divided by M summation M. So again, you see the center of mass only and only depends upon the mass distribution, not on any external force. There is no factor on which the center of mass, no external force factor on which the external center of mass depends. So very, very important. Now we have a generalized formula for this, for the center of mass n particles. Now we will see a numerical based on it. Let's say if you have two particle of masses m1 and m2, they are located x distance at x is equal to 2 and x is equal to 8 respectively. So we need to find the position of center of mass. Very easy question. M1 mass of the particle is given and its position from the origin is given, that is 2 meter. Similarly, M2 is given and the position from the origin of this M2 mass, that is given to be 8 centimeter. Okay. So we need to find the position of this center of mass. You know that if M2 is greater than M1, of course, the center of mass position will be slightly towards the greater mass, right? So we can easily find the center of mass formula. We have to apply this mass weighing formula. We cannot use this formula, x1 plus x2 divided by 2. Why? Because the masses are different. M1 is not equal to M2. So always remember this important point. So M1 x1 plus M2 x2 divided by M1 plus M2. So M1 is given 2, x1 is given 2 plus 3 into 8 divided by 2 plus 3, that is 5. So 4 plus 24 divided by 5, that is 5.6 meter. So very easy question. Okay. We will again practice similar questions to build stronger concepts. So let us consider three particles having masses 1 kg, 2 kg, and 3 kg. They are located on x-axis. X is equal to minus 2 meter, x is equal to 0, and x is equal to 4 meter respectively. Find the center of mass. Now, again, we will draw a reference line. Okay, we have origin. Now we know that x1, this x2 is at origin. So this is the position of x2. That is origin. And what is the position of x1? That will be towards left because that is in negative x direction, that is minus 2x. Similarly, what will be the position of x3? That will be in positive direction, so that will be 4 meters. Again, we have to use this simple uh, weighing average of the positions, and m1 x1 plus m2 x2 divide plus m3 x3 divided by m1 plus m2 plus m3. So m1 is given, x1 is given 1 into 2 minus 2 minus 2, 2 into 0 0, 3 into 4, that is 12, divided by the total mass 1 plus 2 plus 3, that is 6. So easily you can calculate, and the answer will be 1.67 meter. So any doubt up to this point, you can think and you can ask. Now you have some uniform bodies from where we can calculate the center of mass. And as I told you in the you know previous slide, that the center of mass of a uniform body always lies at the center of the body. So if you have a uniform road, okay, let's say this is the length of the road. So the center of mass is always at the center of the road. So if you draw, this is my x-axis. Okay. So of course, if this entire length is L, so this distance that will be from the origin, that is L by m2. So that means at center, the position of center of mass is simply at L by m2. Similarly, circular ring, you can draw a symmetric axis, okay, and the center of mass always lies at the symmetric axis of the uniform body. So that is at the center. For uniform circular disk, center of mass again is at the center. For a solid sphere, center of mass is at the center. Semicircular road, then again you can draw a symmetric axis. Okay. So then this distance from the symmetric axis, that is 2r by my pi from the center of arc. So this is the position of the center of mass. That is 2r by my pi. And again semicircular lamina, The on symmetric axis, the center of mass lies at a distance of 4r by 3. So again, very, very important concept. That important concept is, for a symmetric body, center of mass always lies at the axis of symmetry. I hope up to this everything is clear to you. Now I have given you this question, no, that consider a boy walking inside a boat. Initial situation, the center of mass is here. Even if the boy is walking towards right or towards left, the center of mass will not change unless and until you provide some external force to change its position. So if there is no horizontal force acting on the system, then center of mass remains at rest. It will remain the same, it will remain fixed. But if you apply some external force, then what happens? This external force will change the velocity of the center of mass. Okay. So velocity of center of mass will change, then ultimately the position of center of mass will change. But the internal forces, they don't have enough power to change the position of center of mass. Only external forces is responsible for this. Now we will understand what are internal forces. The forces which is acting between the particles. Let's say if you have a gas particles, they are in continuous motion, right? So they are exerting force on each other, right? So then let's say helium gas filled in a container, so the particles are applying a force on each. This is internal force, okay? And if one particle is exerting force on the another second particle, the second particle will exert equal and opposite force on the first particle, right? So this is internal forces, and they don't change the center of mass position. Okay, the boy pushing the wall of the boat, nothing is going to happen. But if you talk about the external force, it will always act on the system from outside. Okay, so for example, and of course it will change the velocity of the center of mass. So of course the motion of the center of mass will change, like water current that is pushing the boat. Okay, so it will lead to change in the center of mass position. So internal forces, they don't affect the center of mass position, but external forces do affect the center of mass position. Lastly, we will discuss this numerical. Two particles, this is PYQ from JEE main. Two particles, 2m and m, they are placed at a distance given 1, 2, 3, 3, 4, 5 respectively. The coordinates of the center of mass we need to find. So always write the formula, vector formula, then substitute the value, and then simplify carefully and check the option smartly. Okay. So using the vector formula, we can write what is the vector formula for the center of mass. That is summation mi, that is summation miri divided by summation mi, right? So miri vector. So here we can write this is m1 r1 vector plus m2 r2 vector divided by m1 plus m. Here m1 mass is 2m, m2 mass is m. So simply you can write 2m r1 vector plus m r2 divided by 2m plus m. So you can simply put the value. R vector is 1. We not need not to do in I cap, j cap and k cap, because we need the coordinates only. Okay, so we can simply write 1 comma 2 comma 3 plus 1 into 3 comma 4 in comma 5. So if you do that, it will be 2, it will be 4, it will be 6, and we can add x to x, that will be 3 plus 2, that is 5, 4 plus 4 8, and 6 plus 5, that is 11, divided by 3. So the answer will be 5 by my 3, 8 by my 3, and this is 8 by my 3 and 11 by my 3. So I hope you understand this thing. So this is all about today's class. Thank you, everyone. We'll see you with another chapter.